I like these old motors. This one here is, I think it's a General Electric 3 horsepower, 3-phase. And it's just pretty nice looking motor. And about 80 years old. And they kind of made a change shortly after this and started looking more modern. I don't know, they're probably better, more efficient. I don't know. But I've been asked a couple of times why I don't go with the inverters, the VFDs. And the reason is you have to have one for every machine. And you have to integrate it to the machine. And a machine like this, it doesn't really need to be speeded up or slowed down, so I don't need that function. I don't know very many people that do use the VFDs. I have a machine I think it would be okay to use it on. I would use it to speed up the motor so I wouldn't have to change a pulley, and I could keep it kind of down in the low range and use the full torque of the motor and speed it up for high range. That showed a spindle molder woodworking machine, and I think it would be suitable for that. But one of the things that you got to be very careful about doing is speeding up machines that aren't designed to be sped up. Like that spindle molder, the spindle's designed to go to a high speed, and you change the pulleys. I'd use the VFD to get around changing the pulleys, I suppose. Yeah, people out, joggers and everything out here. It's pretty early. Oh, what a nice drill press. Well, hey, I'm going to go inside and have a look at that American Rotary Phase Converter. I got the cover off. I'm going to mount it on the wall. So I'll head in there. See you in there in a second. Yeah, put the box up here on the wall. Looks pretty sharp, huh? Yeah. Okay. Hey, on those VFDs, one of the other problems with them, I'm not against them or anything, I think they're pretty cool, is if you got 2-speed motors like on the jig board here, and the hard-inch machines like the Chucker, I don't think they work with 2-speed motors. And then you got to integrate them with your with the controls on your machine. And this machine here, you lift the lever up here, and it's got all this linkage that goes to a switch. Then you pull it down, and then that's the brake. So you have to get into the machine and hook the VFD up to it. And I don't know, there's a lot of talk about these things. Let me get over here. Move stuff around here. Boy, it's crowded, and I'll tell you. It'll be better to get this stuff straightened up. These Monarch 10EEs really have, can have some drive problems. From people overloading them and stuff like that, and things can get lost out of them. People need to replace them, and kind of what worked out the best, sort of, other than restoring the drive, is going with the VFD, and they then getting an inverter duty motor, 5 horsepower. And it's sort of like I don't know if you can get much over 5 horsepower with a VFD. The factory replaced the DC drive with the VFD, but it's a real heavy-duty unit. And like this machine here is the Fibertron tube rectified DC drive, 5 horsepower. But the VFD to replace it that they come up with is up to 10 horsepower. So you have to take that into account, that you're going to lose power as you reduce the speed using a VFD. You just lose a bunch of power. So it's this and that. Now on lathes, like this old axles in here, it's really kind of a bad idea to speed them up using the VFD, because they're not designed to run faster than they're listed. This one's 1127. They did speed these up somehow. You could order up to 1500 RPM, but to run the machine at like 2000 RPM would be pretty risky, because the oil cavitates, gets bubbles in it, and it gets to a point where there's enough air in the oil that it's not lubricated anymore, and the little bubbles kind of like explode between the interfaces of the gears, and it starts eroding the gears away. And it starts looking kind of grayish on the gear teeth as the hard facing gets eroded away from the cavitated oil. So can you speed up a lathe faster? You can, and people do it, but you can't run it all day like that, and only for short periods. So, and myself, I just don't do it. I'm not going to speed up this axle sound, or take a lathe that only goes to 500 RPM and gear it up, or use the VFD and make it go 1000 RPM. And that's another problem with lathes too. They have a high start load, and so I don't know. The safest bet and kind of the easiest way to go, I think, is with a rotary converter. If you got multiple machines, I think I have nearly 10, from 1/3 horsepower to 5 horsepower, and that would mean 10 VFDs, and I don't know. I guess you just kind of have to go machine by machine. But I just wanted to mention that I am considering it for one machine, but for these other machines, I don't know. Maybe the cutter grinder might be something to consider, but I don't know. It works fine like it is, and I don't know. If things work, I don't feel like changing them. But be aware, speeding up like gearhead lathes, about that oil cavitation thing happening, and it's kind of a slow kind of a thing, but once it starts wearing the gears like that, they can start kind of chipping on the faces. So you kind of have some hidden damage that's kind of creeping up on you. Well, okay, I'm going to kind of kick around and get this. Oh, I was going to show you all that. Yeah, we're going to get over here. Here's the inside of the American Rotary Phase Converter, and it is really sophisticated. It's got just a lot more going on there than what used to go on inside things. Here's this to the switch on the cover. Now here is old time. People used to use just this old-time static phase converter, and it's got this black capacitor down there, and then to get a motor started, a 3-phase motor, like in your lathe or something, then they claim you get about 2/3 of the rated horsepower, because you only got 2 legs running, but I think it's actually 1/2 or less actually doing that. And people did this for years. And it was kind of a problem on lathes like the Hercules Ajax or other lathes that don't have clutches. You know, if you had an old lathe with a clutch and a static phase converter, you could generally kind of get your lathe going. This here was a kit. These things here are about 125 bucks in the 1980s. And if you got the kit, I think it was like $79. But things have come a long ways from this to this. Because people were using this, then they would get an idler motor going. But this here gets the this idler going. I suppose by the two black capacitors here, then these are run capacitors, I would guess. for the third leg that's being generated by this stabilizing it out. Then it's got a circuit board here to further kick this stuff in and out, make it run smooth. I think it's going to be pretty cool. I'm going to have this right here by the machine, so the machine that takes the most power will be the closest to it. I just don't think there's going to be any problem. Oh, I was gonna have to say, sometimes utility three-phase power is not all it's cracked up to be. Some of the rural places around here, the three-phase power is used for pumping water, irrigation and stuff like that. And in some spots, the utility three-phase can be considerably out of whack. And I was helping a fellow get a Monarch 10 double eagle, and it's the later version of this that has the regenerative, so all solid state direct current drive, and it's really sensitive. And he had CNC equipment that was going haywire, couldn't make work too, and he had an electrician come. And this electrician goes, I don't know how the utility makes this happen. It's so bad. But anyway, the utility did make it a little bit better. But he ended up having to get a power conditioner and before he could make his stuff work there. And it was huge, boxes and stuff like that. And so sometimes utility three-phase isn't all that great, you know, been there. And it's just kind of like that. But I'm quite excited about this, and I'm going to take my time and put this in. And I want to mention, it's really, they have a pretty thick book, and I started looking at it. It's really very simple hookup. But if you're not familiar with electrical hookups and motors and stuff, you better have an electrician come help you put this in, and it won't take that long, you know, for the electrician to do that. It's really straightforward. But you don't want to electrocute yourself, and there's some things about this kind of thing, you know what I mean? I'm going to have a cut off, make sure the whole thing's cut off, because even if the switch is off, you know, there's still on the rotary converter, there can still be power going through the light lines. Okay, well, I'll get back if I find anything interesting, and I'll get going here pretty quick, okay?